What do these four things have in common? The probability of a mine flooding, forecasting the value of drought resistance in the Horn of Africa, forecasting fuel requirements for the Iraq ground war, and the probability of breach. They're all catastrophic risks. Most people think they're impossible to measure, and most people would be wrong. Are you like most people? If so, like him? If so, I've got some good news for you. They've all been measured before. And you don't need to be a rocket scientist. You don't need to be a movie producer. You don't need to be a professional sports general manager to do this, although they measure intangibles with uncertain outcomes like this all the time. So what are the uncertain things that you might want to measure or predict? I've got one. It's a hairy ball of uncertainty wrapped in a thick veneer of intangibility. How about predicting the value of trust? That's our aim, predicting the value of trust. And that's why our talk is titled Trust by Design. So we plan on answering these three questions for you. What is trust by design? What are the challenges in implementing it? And why on earth would you want to? And for those of you who just can't wait for anything, who read the last page of a murder mystery first, or who, like this guy, start dinner with dessert, let me quickly tell you the moral of the story. Trust by design is choosing what and how much to improve based on value. The what are things like security, availability, scalability. We informally call these ilities. The how much are maturity levels for the ilities. And value is ROI, as we'd like to say, return on ilities. Now, Jason will define trust for us and the role Iron Man plays in what we call trust by design. Go get him, Tiger.
Thank you. Okay, so before we get started, I want to address the elephant in the room. So some of you in the front row have probably noticed the lovely black eye that I'm sporting. I want you to know that it has nothing to do with Rich. Rich is not prone to violent outbursts and would never raise his hand at me in a fit of rage, even though I could have been and should have been better at rehearsals. Rich is also a snappy dresser.
Snappy, yes.
Thank you.
Thank you.
You were supposed to say thank you. Yeah. All right. So now that we have that out of the way, so what is trust? So the literal definition of trust is the firm belief in the reliability, truth, ability, or strength of someone or something. And trust is table stakes for establishing long-term relationships with customers. And it doesn't grow unless you consistently meet or exceed their expectations, and particularly expectations in terms of capabilities like security, reliability, scalability, availability, again, the ilities.
Ilities.
And customers have both implicit and explicit expectations about capabilities. And when they're found to be missing, the implicit becomes the explicit, and trust erodes. And like most growing businesses investing in R&D, we experience tremendous growth in our organization and our portfolio. So ensuring consistency across dozens of engineering teams and hundreds of engineers and millions of lines of code became hypercritical for ensuring that we're protecting and growing trust with our customers. So we asked ourselves, what do they call a quarter pounder with cheese in Paris? And then the conversation devolved into 30 minutes of our favorite Pulp Fiction quotes, which was super fun.
I liked it.
Not super productive. And we came back to what the real question is. How can we ensure that we're consistently meeting and beating expectations such that we don't become just another service provider, but become a trusted partner and marketable differentiator for our customers? And it really starts with maintaining and the highest levels of operational maturity. So our culture is built around operations and security as priorities 1A and 1B, with everything else following after, because all the cool features and capabilities in the world are honestly pretty meaningless if they're not predictable or consistent or secure. And we know from our own experience as customers that when things just work all the time, as expected, they build trust. So this is the kind of questionable, wildly unsafe, arguably life-threatening trust that we want to build with our customers. It's highly unlikely that we're going to ask them to let us use their backs as a saw table, but we want that level of trust to be such that were we to ask, they'd say, dude, can I borrow your gloves and knee pads?
Damn straight.
And Rich would let them borrow his gloves and knee pads. But just saying security and operations are top priorities is honestly pretty hand-wavy. And we needed a better way to define and evaluate and improve our engineering standards because as Peter Drucker, who's the father of modern business management, so famously said, you can't measure it, you can't improve it.
Amen.
Amen. So we developed the Operational Maturity Model, or the OMM, also known as Iron Man internally, and I'll explain why in just a bit. But first, what is the OMM? So as an engineering organization, we needed to document our opinions about how to build systems, and more importantly, how to evaluate and continuously improve them. And in R&D, we have a tremendous amount of experience across engineering and operations, security, architecture, customer support, literally centuries of experience across the organization. This guy probably has close to 100 years just by himself.
That's right.
By himself. But none of us is a subject matter expert in all of those areas. So we decided to write a new operating system for R&D at Twilio. And we focused it in a few meaningful dimensions to formally establish our engineering, security, and operating standards. And specifically, we focus on information and AppSec, architecture, resilience, build and test capabilities, operations, and support. And we chose these dimensions because in our experience tells us that failing in any one of these means that we can't deliver the products that our customers want with agility and velocity, quality, security, again, the ilities. So we identified subject matter experts in each of these areas with a combined 100+ years experience across the dimensions. And we asked them, what questions should we be asking? And more importantly, what answers should we expect from world-class technology products? So questions about information and application security and support of compliance regimes like SOX and HIPAA and GDPR. Questions about how you build and test your software such that you're catching issues before they reach production and impact your customer experience. Questions about your architecture, your resilience, your fault tolerance, how you instrument and operate your systems. And then for products that have the luxury of having a customer care team support them, questions aimed at determining whether you've armed those resources with the necessary training and documentation to provide world-class support when your products are out in the wild. So we had the questions to ask, and we had the answers we expected, but we needed to delineate the various maturity levels to understand where we were and what it would take to get to where we wanted to be. So we set 3 bars. So aware means that you've met the minimum bar for a given dimension. Products that are aware are typically in the alpha or private beta state. They're early in their development life cycle. Scaling is next and shows you're well on your way to a world-class service, but you're still delivering betterments. Products that are scaling are typically in the public beta state. And then finally, Iron Man. So the highest bar for demonstrating your commitment to employing world-class security, engineering, and operational standards. And we chose Iron Man because the character represents battle-hardened, cutting-edge technology wrapped in contextual communications, which is what we want Twilio products to deliver. And the process is pretty straightforward. So we have all of the dimension guidance. We have teams self-evaluate their systems and assign a grade. Once that's complete, we pull in the subject matter experts, and we have those teams evaluate and validate the grades. And then through these evaluations, we're identifying betterments required to achieve Iron Man. We put those in the product backlog, schedule their delivery to customers, et cetera. And then we treat the operational maturity model much like we do our products. So we view it through the same lens of continuous improvement and bar raising. Every quarter, each dimension undergoes evaluations and betterment opportunity assessments so that we can incorporate changes in capabilities of software or security, infrastructure, changes to compliance regimes. But we also realize that ain't nothing in this world for free. Now, Lil Wayne and Big Sean will tell you that you don't achieve 5 nines by accident. Okay, actually, they wouldn't tell you that unless we told them to tell you that, because I don't think they understand that 5 nines of availability is 5 minutes of downtime in a year, but whatever, it's still true. So it takes time and effort, and it really starts with culture. And we made a decision early on to be a customer-first organization. So whether our customers are internal employees, like the case of my organization, or external individuals and businesses, everything that we do is with their experience front and center. So this influences everything from the people we hire, to the products we build, to how we build them. And the OMM looks great on paper, and if you ask an engineer if they want to build something amazingly resilient and secure, you're probably not going to hear many no's. But humans are generally change averse, and engineers, myself included, don't typically embrace process or meetings. So this needed to be a grassroots effort. We didn't want this to be a top-down, thou shalt type of effort. or the success of the program depends on the influence of one or two individuals. Unfortunately, Rich and I came to the painful conclusion early on that we cannot rely on our looks or our charm or wit or questionable sense of humor to get this done. So you have to identify those folks that want to be part of the core team of influencers that's going to raise the bar for your organization. But you should also be cognizant of the impact that this will have on engineering organizations. Excuse me. So rolling this out required a time commitment on the core team and everyone involved with the evaluation, measuring, and delivering betterments. And we're a software company, so we're investing in a solution we call Jarvis, which is just another really very intelligent system. For Marvel fans will recall Jarvis is the digital assistant with the lovely British accent who helps Tony Stark in Iron Man, which is the name of the program. And so initially, we're internally open sourcing this so that all of our engineers can contribute the time and code to automate the evaluation and grading of everything the machines can analyze for us. Because we firmly believe software solves most problems, with the obvious exception of making he and I funny or good looking, but most problems, yes. Right? Yeah, most problems are solvable with software. So this is the executive dashboard for Jarvis, and this is where all employees go to get insights into the maturity levels across product groups, products, and then individual systems that make up a product. And this also becomes the definitive source of truth for all maturity data across all systems and dimensions. So we have the OMM. We're raising the quality bar. We're increasing the trust that we have with customers. And we're using software to make all of this lightweight and transparent. But how do we take all of this data and use it to influence what we do or how we do it, or even how much we're willing to spend on it? And with that, my nonviolent friend is going to come up and blow your minds away with science.
Thank you. Thank you very much. All right, Jason, question for you. What's the ROI, return on abilities, return on investment, on 3 nines versus 4 nines versus 5 nines of availability?
12.
Exactly. So while OMMs specify the what and the how of operational maturity, it doesn't speak to why. Fortunately, Trust by Design adds some quant magic to OMMs. That magic helps us understand why. We want to make one improvement over another based on ROI. And normally I would demonstrate that magic right now, but I found that people get downright snappy if I jump to code and don't first address a few intellectual and, more importantly, emotional challenges. The first challenge is measurement. It ain't what we think. The second challenge for most of you is probabilities. It certainly isn't what we think. Third is impacts. That's actually easier to predict than we think. So let's look at our first challenge, measurement. Again, this is for determining value. So for those of you who think something is immeasurable, the concept or misconception of measurement is probably the most important obstacle for you to overcome. If you thought breach, that's impossible to predict, or you certainly can't determine the value of drought resistance in the Horn of Africa, then this is your slide. So let me ask you something. What is measurement? We usually hear to quantify something, to compute an exact value, or to reduce to a single number. Would you be surprised to learn that measurement professionals, otherwise known as scientists, actuaries, and statisticians, would say something completely different?
Rich, I'm shocked, and I actually don't believe you.
That's shocking, isn't it? You are shocked. I knew you'd be shocked.
Yeah.
So, but why take our word for it? Let's see what some measurement pros have to say on this topic. Some of you may know this gentleman, Albert Einstein. As far as the propositions of mathematics refer to reality, they are not certain. And as far as they are certain, they do not refer to reality. Bertrand Russell, also known as Bertie. Although this may seem a paradox, all exact science is based on the idea of approximation. If a man tells you he knows a thing exactly, you can be safe in inferring that you are speaking to an inexact man. And you all may know this one from George Box. All models are wrong, but some are useful. Claude Shannon, the father of information theory, and by the way, this conference wouldn't be happening without him. He defines information as the amount of uncertainty reduction in a signal. The point is, Nobel Prize winning, history-making, world-changing scientists see measurement as a reduction, and not an elimination, of uncertainty. So as we look to measure the value of OMMs, we need to keep the uncertainty reduction theme in mind. So now on to our next challenge, probabilities. It's a huge stumbling block for some. Let's go huge stumbling block for some, particularly for those who remember just enough stats from college to get it all wrong. So, where on earth did you get those probabilities? This is what my mother used to say to me daily. My answer to my mother was Bookies. When a bookie says something has a 90% chance of occurring, do you know how often they're correct?
12.
90% of the time.
Damn it.
Do you know that when a bookie says something has an 80% chance of occurring, do you know how often they're right? Somebody else? No, go ahead.
12.
No, 80% of the time. So what makes a bookie so good at predicting the future? It's rapid feedback on predictions, it's playing with money, and it's the fear of pain. Pain they will inflict on others, or that will be inflicted upon them when bets go awry. And making predictions is actually a trainable skill, and that's what we do. We actually train our SMEs up to be bookies. I've participated in one of the largest long-going studies on this over 20 years. We've seen over 1,000 SMEs trained to be virtually indistinguishable from bookies. And you don't need to take our word for it. How many of you, by show of hands, have read or heard of this book? New York Times bestsellers? Oh. Many of you. This is an erudite, intelligent crowd. So Obama has this on his top 8 books to read. So I'm not surprised that many of you have read it. It's largely about making judgments under uncertainty with chapters like Taming Intuitive Predictions and Rare Events and Expert Intuition. Kahneman's methods have been applied to medical diagnosis, legal judgments, intelligence analysis, finance, military strategy, and even cyber. And the author's research culminated in a Nobel Prize in economics. So our bookie skills can help us generate probabilities, particularly when we think we lack data. But there's some more good news I have for you. We often have more data than we think, and we need less data than we think when making bets. So to that end, let's see how playing with marbles, you're going to like this, can help us refine our predictions. In this case, about something highly uncertain, potentially catastrophic, and OMM related, security breach. After that, after all, I'm the security guy, but this could be applied to any operational concern you have. So again, more on probabilities. So you have a jar that has red and blue marbles in it. You don't know how many. It could be 5, could be a billion. You're highly uncertain. Red is for breach, and blue, no breach. You randomly draw 5, and if you were asked to bet on how many are in there, the math tells you it's somewhere between 1 and 45%. It's not saying it's the truth. It's just putting the odds in your favor if you were to be asked to bet. So you put those back, and you randomly draw 15 more. And your best bet is, as stated, between 1 and 18%. Again, not truth. We're talking about gambling here. Now, put those back. You draw 75 more. You have more data now. Your uncertainty is significantly reduced, but it's not eliminated. It's between 1 and 8%. Just so happens that this is the breach forecast for Fortune 500 healthcare based on public breach data. I think that's pretty cool, don't you?
It's amazing.
You're welcome. So this is an example of how actuaries use probabilities when faced with seemingly irreducible uncertainty, which we're all faced with, I think, all the time. I should add, my co-authors' books are required reading for the Society of Actuaries exam. Our new book extends that to cyber, and 10% of the exam questions come right from our books. So perhaps you can take our word on this subject just a little bit. So we covered the challenges with measurement and probabilities, and now comes financial impacts. This is key to making bets. After that, we're going to do a quick probabilistic programming demo that hopefully brings this all together for you. So hold on, there's going to be some horrible code coming your way soon. So forecasting financial impacts. Win $1,000 if you guess the average weight in tons of an adult male African element.
And the answer is not 12. I tried.
Yes.
Not
You're bad at this. So anyone want to make a bet? No cheating, right? Okay. So unless you grew up in the circus, unless you're a zoologist, or frequently on safari, you're likely highly uncertain about this. This has been tested. So let's make this more interesting for you. I'll let you put a range on this, all right? And if the true value is within that range, you win. Because you're all greedy, I can tell, I bet you're going to put this enormously large range on this. It's not really what you think, you're just greedy. What we really want is what the pros call is your 90% confidence interval. So how do we do that? You adjust your range until you think your chances of winning $1,000 is just as good with the spinner here as it is with the elephant bet. Measurement pros call this making an equivalent bet. And believe it or not, this is how bookies forecast impacts. And it's how we do it too when we're doing trust by design. Okay, all right, we're ready. Flaming hibachis. It's demo time. We're going to focus on the OMM security dimension. Again, I'm the security guy. We could choose any OMM dimension about scalability, availability, whatever abilities you have, all right? Our goal, in this case, is to determine the value of OMMs in reducing the likelihood and impact of breach. Notice the focus on value in OMMs. This is an immutable feature in Trust by Design. A key part of this demo is something, by the way, called a Monte Carlo simulation. Anyone here heard of Monte Carlo simulations? A few hands. A few. I saw that. She was quick to raise her hand. So Monte Carlo simulations were originally invented by scientists in the 1940s in the development of the first atomic bomb. Despite its nefarious start, they found that randomly running thousands of trials, we're going to do hundreds of thousands of trials, but running thousands of trials was a way to work out probabilities with highly uncertain inputs. Our demo essentially is a Monte Carlo-based gambling machine or a gambling robot. It consumes bookie-generated collective intelligence and helps us make better bets to get better ROI, given our uncertainty, which is a lot. Again, it's not the truth, it's just better card counting with OMMs. Here we go. Be prepared to be not entirely impressed. All right. All right, let's do this. Okay. Let's make this a little bigger, I think. How's that? Can you guys see that okay? Is that all right for you? All right, so first thing I talked about were probabilities, right? The idea that bookies are going to make bets on things. In this case, let me show you what this looks like. I'm going to show you what it looks like for bookies to make bets on OMMs. So here we go. So we have 3 OMM dimensions for security. We have the systems assurance process, we have the vulnerability management process, we have the incident response process, and we have 2 additional variables. In this case, bookies are making bets on applications, in theory, applications that could be breached. In this case, what we're doing is we're actually training a model. We're actually doing data science on humans. Go figure. I just show 5 examples here. Typically, you'd have between 100 to 200 examples that you'd have your bookies make bets on. So we've done that here. So now we're going to talk about the next subject that was 90% confidence intervals. I know I talk fast. I'm like Ricky Bobby, like to go fast. So let's look at this real quick. What does it look like to make your 90% confidence intervals? In this case, we've taken in the idea of records that could be compromised. So you might have a whole portfolio, you might have an application where you say, all right, we have somewhere between 10 million and let's say 5 billion records. Our model actually takes that in and spits back data values. It actually takes in our uncertainty and the industry's uncertainty. I'll just run this a few times. So each time it's going through the model and it's taking into consideration our uncertainty. Just so happens that Yahoo, the Yahoo breach, guys, was over, what, 1 billion records? They didn't tell us exactly. We're actually uncertain about it. We know that it was $16 million in impact. It was actually largely legal impacts with some IT impacts. There was this whole thing about them being sold to Verizon and having a $350 million discount. That's bad for Marissa. But we're looking at about 16 million in impact. Our model actually captured that. Before that actually happened, we captured that impact within a 90% confidence interval. Again, we're taking in bookie bets. We're taking in industry data here. We're highly uncertain, though. We have a lot of uncertainty, but it was still good. So let's ask some questions of this model. So the gambling machine, we're going to do a bet on 25 applications, and we're going to look at what the gambling machine does. Think of a roulette wheel spinning, and every time we spin it 300,000 times, right? But here's a few spins of it, what it looks like. All right? I'll explain this to you. So we spin it. Here's spin 1, right? See, it says 1. We had 0 impacts. Here's spin 2. Actually, that was spin 50,001. And we had an impact of $473,000. And here's spin 100,000 for year one. We had a $4 million impact, and then we had an $8.9 million impact. Well, that's great. We take all this data and we actually turn it into a virtual database. It's actually like a crystal ball that allows us to start asking questions. Now we're going to be doing what we call probabilistic programming. We're going to be asking questions of the data to predict future outcomes, particularly financial outcomes. So let's say, all right, what's the chance of losing $10 million in year one based on this? Again, it's not truth, it's extreme card counting. Oh, we have a 20% chance of losing $10 million in year one. Let's look at a year one with $50 million in loss. We look at that. Boom. A 1% chance. By the way, I'm running this in R. This is the RStudio IDE. For those of you like R, go R. Woo. All right, so what's the probability of losing $50 million one or more time in 3 years with modeling out the improvement in OMMs 1 year to next? So we have multiple things, a multidimensional question we're asking here. Multiple years, improvement in OMMs moving towards, let's say, Iron Man. So what does that look like? That's about a 2.4% chance of losing $50 million one or more times in 3 years, taking into consideration improvements. All right. So what should I expect to lose on average? They call this expected loss. You may have heard this if you're, you hang out with actuaries all the time, right? Yeah.
All the time.
They talk about this.
Every weekend.
Trust me. So $6.5 million. How about in year two? Again, expecting some OMM improvements. How much should I expect on average to lose in year two, let's say? All right, 5.2%. By the way, let's hope you have good cyber insurance. All right, so cost of controls. Let's say the cost of controls, the cost of improvements between year one and year two, I invested $1 million in people, process, and technology. Let's run that. Boom, 23.7, call it 24% improvement. That's okay. Let's assume, though, that sales said, hey, security folks, if you were to go PCI compliance, you know what PCI compliance is, we think we could, and let's say you speak lower bound, upper bound, we think we can get between $10 million and $50 million in sales. Since we don't believe them usually, we'll go with $50 million. We'll take the lower bound. Let's model that. So we add that in. So it's an opportunity gain of $10 million between year one and year two based on the improvements in OMMs. What's the return? It's 1,023%. Again, not truth, it's for gambling. Why is this important? First of all, it's mathematically unambiguous and entirely consistent. What's going to happen in a large company is you're going to have competitions where you're uncertain. Should I improve this? Should I improve that? Should it be what I do? Should it be what you do? Should it be a feature? When you're uncertain, if you're certain, you know what to do. When you're uncertain, you do things like this to start prioritizing to help you make decisions. This is exactly what trust by design is, the melding of OMMs with some badass quant skills, all right? So I say. Mirror, use as separate display. And go back to our presentation. Okay, so our demo was a mashup of operational maturity models, gambling machines, and flaming hibachis in R. So we also asked Albert, Bertrand, George, and Claude their thoughts on measurement. They all agreed it's uncertainty reduction, not an impossible standard of exactness. We also hope we addressed intellectual and possibly emotional issues with measurement. And now we're going to conclude our talk by answering the question, why on earth would you want to do this? Go get him, Tiger.
Thanks, Barbara.
All right.
Okay, so I'm assuming most everyone has either seen the movie or read the book Moneyball. So the image on the right is Assistant General Manager and Statistician for the A's, John T. Podesta, played by Jonah Hill.
Brilliantly played.
Yeah, sure. Okay, Jonah Hill fan. Go Jonah. But what were the A's after? So they wanted to know how to compete with the likes of the big budget teams with a fraction of the budget. So they knew they couldn't spend their way to a championship. So they used data and modeling to determine what would give them the best ROI for winning. And one of the biggest epiphanies that the A's found was that RBIs, or runs batted in, did not highly correlate with wins, which seems pretty counterintuitive. You bat a run in, you score, you do this a bunch of times, you win, right? Well, apparently just getting on base correlates much higher with wins. And even more importantly, the cost of hiring people who just get on base was significantly less than those who had high RBIs. So they used the predictions from their models and made very targeted investments in players who simply tended to get on base. And as the A's ran with this, they started winning huge at tremendous ROI. So admittedly, baseball has less moving parts than the infinite complexities of building applications and products and companies. And conversely, as I stated earlier when defining trust, the platforming ecosystem really only has one rule for winning, and that's execute on customer implicit and explicit expectations. And how do we do this? By codifying the ilities as OMMs with the singular goal of meeting and beating customer expectations to build trust. But what if you can't do everything or not all at once? Then you prioritize OMM execution using bookies and collective intelligence and gambling machines, or quantitative risk management, as we call it internally, to identify those dimensions that are going to give you the best ROI for winning.
Yeah, that was really good.
Was it? Thank
you.
I thought nailed
so we're not done yet. So it's our way of focusing on the plays that make wins. It's trust by design, which is nothing more than choosing what and how much to improve based on value. Value is the why. And we understand value quantitatively, predictively, dare we say scientifically, as return on
ilities.
Ilities, yes. And our hope, this is our hope, that trust by design will emerge as an industry best practice, particularly within the uncertainties and intangibilities that make up the platforming ecosystem. So for questions about becoming bookies, wielding flaming hibachis, or which one of us is Captain America versus Iron Man, we can be found at the bar.
Get out. Get out.
Thank you.